Hi everyone, this is Nadia Rubayat. I'm one of the lecturers for the CSC department of BRAC University. In this example video, we will see how to draw a state diagram from a given sequential circuit. Here we have a sequential circuit using JK flip-flop. Now, in order to find out the state diagram, we have to note down our present states, next states, and the input and output. In this case, we have our present states as A and B, and our next states as A plus and B plus. Here for the first flip-flop, our inputs are JA and KA, and for the second flip-flop, our inputs are JB and KB. We also have an external input X here. There is no external output given here. Now our first step to draw our state diagram is to find out the input equations of the flip-flop and the output equation. In this case, from the circuit, we can see that the equation for JA will be B, the equation for KA will be Bx prime, the equation for JB will be X prime, and the equation for KB will be A XOR X. Our next step is to draw a state table using the equations. Now, in order to draw the state table, we will give A, B, and X as our input. For 3 variables, we will end up with 8 possible combinations. Now, in the first combination, where A is equal to 0, B is equal to 0, and X is equal to 0, the value for JA will be 0, the value for KA will be 0, the value of JB will be 1, and the value of KB will be 0. We will note them down in our state table. For the next combination, where A is equal to 0, B is equal to 0, and X is equal to 1, the value for JA will be 0, the value for KA will be 0, the value for JB will be 0, and the value for KB will be 1. We will again note them down in our state table. In a similar manner, we will find out all the possible values for JA, KA, JB, and KB according to the combinations. Our third step is to find out the next states for each of the combinations. Now, in this case, we need to be familiar with the characteristics table of JK flip-flop. So in JK flip-flop, whenever the value is 0, 0, there is no change, which means the present state and the next state will be equal. When the value of JK is 0, 1, it basically follows reset, which means the next state will always be 0. When the value for JK is 1, 0, it follows set, which means our next state will be 1. And finally, when our value for JK is 1, 1, it follows the toggle operation, which means the next state will be the opposite of the previous state. Now, in the first combination for JA and KA, the values are 0, 0. So as a result, no change will happen. So the value of A will be the value of A plus. In the next combination, the value for JA and KA are 0, 0 again. So the value of A and A plus will be equal here. In the third combination, the value of JA and KA are 1, 1, which means this is a toggle operation. So the value of A is 0. It will be reversed in the value of A plus. So it will become 1. In the fourth combination, the value of JA and KA are 1, 0, which represents the set operation. So the value of A plus will be 1. In a similar manner, for all values of JA and KA, we will figure out the value for A plus, and for all values representing JB and KB, we will find out the values for B plus. After completing our state table, now we will move on to the state diagram. So in this case, our present states are A, B, input is X, and our next state are A plus and B plus. We have 4 possible combinations for the present state here, which are 0, 0, 0, 1, 1, 0, and 1, 1. We will represent them as circles in our state diagram. So in the first combination, if the present state is 0, 0 and the value for X is 0, our next state is 0, 1. So we will give an arrow directing from 0, 0 to 0, 1. And on the arrow, we will give the X's value. In the next combination, the value for X is 1 and the present state is 0, 0, where the next state is 0, 0. So we will give a self loop on 0, 0 and write down the value on top of the arrow 1. In the third combination, our present state is 0, 1, the value for X is 0, and our next state is 1, 1. So we will give an arrow from 0, 1 state to 1, 1 state and write down the excess value on top of that arrow. In a similar manner, we will fill up all the present state to next state transitions and note down the inputs value as well. So this is how we can draw a state diagram for any given circuits.